Have you ever wondered how Python handles mathematical and logical operations? Does it intrigue you how this high-level programming language interprets your commands? Intrigued? So buckle up as we dive into the world of operators in Python. Arithmetic operators in Python facilitate mathematical operations just like your basic calculator. Let's break them down one by one, starting with the most familiar ones, the plus and minus operators. They work as you would expect, adding or subtracting numbers. For instance, 5 plus 3 equals 8 and 10 minus 7 equals 3. Next, we have the multiplication operator, represented by an asterisk. So if we have 4 times 2, Python will give us 8. Then there's the division operator, denoted by a /. Let's say we divide 10 by 2, Python will yield the result as 5. But what if we want to find the remainder of a division operation? That's where the modulus operator comes in handy. It's represented by the percentage symbol. For instance, if we divide 17 by 5, the remainder is 2. And that's what Python will give us when we use the modulus operator. Then we have 2 less common operators. The double asterisk represents exponentiation. So 2 double asterisk 3 in Python means 2 to the power of 3, which equals 8. Lastly, we have the floor division operator, represented by 2 /. It performs division but rounds down the result to the nearest whole number. So if we have 17 divided by 5, the exact answer is 3.4. But Python will give us 3, because that's the nearest whole number that is less than or equal to 3.4. Remember, the order of operations in Python follows the standard mathematical rules, also known as the BODMAS rule. Brackets first, then orders or powers, followed by division and multiplication from left to right, and finally addition and subtraction from left to right. So that's how arithmetic operators work in Python. Pretty straightforward, right? What if you need to compare values in Python? Well, that's where comparison operators come into play. Let's delve into the world of comparison operators in Python. There are 6 of them: equals to, equal sign, not equals to, equal sign, greater than, less than, greater than or equal to, equal sign, and less than or equal to, equal sign. First, we have the equals to operator, represented by 2 equal signs. It checks whether the values of 2 operands are equal. For instance, if we compare 5 equals to 5, Python will return true, because indeed 5 is equal to 5. Next, we have the not equals to operator, got equal sign. This operator checks if the values of 2 operands are not equal. If we compare 5 with 6 using the not equals to operator, Python will return true, because 5 is not equal to 6. Moving on, we have the greater than dunce and less than operators. As the name suggests, they check if one value is greater than or less than another value. If we compare 5 with 6 using the greater than operator, Python will return false because 5 is not greater than 6. And if we use the less than operator for the same comparison, Python will return true because 5 is indeed less than 6. Lastly, we have the greater than or equal to, equal sign, and less than or equal to, equal sign operators. They check if one value is greater than, equal to, or less than, equal to another value. If we compare 5 with 5 using the greater than or equal to operator, Python will return true because 5 is equal to 5. And if we compare 5 with 6 using the less than or equal to operator, Python will also return true because 5 is less than 6. And that, my friends, is how Python makes comparisons. Quite simple, isn't it? For more complex conditions, Python provides logical operators. Let's dive into the intriguing world of logical operators in Python. These operators are the connective tissue between different conditions, allowing us to create more complex, nuanced expressions. The 3 primary logical operators we'll be exploring today are AND, OR, and NOT. Let's kickstart our exploration with the AND operator. It's a binary operator, meaning it requires 2 operands. It returns true only if both its operands are true. For example, if we have 2 conditions, say 5 is greater than 2 and 8 is less than 10, the AND operator will return true because both conditions are indeed valid. Now let's move on to the OR operator. This operator also works with 2 operands but has a slightly different functionality. It returns true if at least one of the conditions is true. So if we have two conditions such as 10 is less than 5 and 7 is greater than 3, the OR operator will return true. Even though the first condition is false, the second condition is true, which validates the OR operator. Last but not least, we have the NOT operator. This one's a bit different because it's a unary operator, meaning it works with just one operand. It simply reverses the truth value. If we have a condition like 5 is less than 2, which is false, the NOT operator will return true because it flips the false condition to true. Logical operators in Python can be quite powerful when used correctly. They allow us to create intricate, nuanced conditions that can handle a variety of situations. Remember, the AND operator requires both conditions to be true. The OR operator needs at least one condition to be true. And the NOT operator simply inverts the truth value. Now you understand how Python processes logical operations. We're making good progress, aren't we? Now, let's put these operators to use and build some expressions. Expressions are the heart of any programming language. They are the building blocks that allow us to perform computations and make decisions. In Python, we can build expressions using a combination of values, variables, operators, and calls to functions. Let's begin with a simple arithmetic expression. Suppose we have two variables, a and b, with values 5 and 3 respectively. We can create an expression a plus b to add these two numbers. When evaluated, this expression will return the value 8. But what if we want to compare a and b? That's where comparison operators come into play. An expression like ab checks if a is greater than b. In our case, this expression will evaluate to true because 5 is indeed greater than 3. We can also build more complex expressions by combining multiple operators. For instance, the expression a plus b checks whether the sum of a and b multiplied by a is greater than the product of a and b. Here, the parentheses are used to change the order of operations, just like in mathematics. How about logical operators? Well, they allow us to combine multiple conditions. Consider the expression a, b, and b, 2. This will only evaluate to true if both conditions are met. If a is greater than b and b is greater than 2. In our case, this expression will indeed return true. Remember, the beauty of expressions lies in their flexibility. You can mix and match operators, nest expressions within each other, and much more. The only limit is your imagination. But don't just take my word for it. Try it out for yourself. Play around with different operators and values and see what happens. It's all part of the learning process. And voila! You just learned how to build and evaluate expressions in Python. It's like magic, isn't it? So we've covered a lot today, haven't we? Indeed, it's been a journey through the world of Python operators. We've explored arithmetic operators, the building blocks of mathematical operations. We've learned about the addition, subtraction, multiplication, and division operators. We've even delved into the more complex modulus, floor division, and exponentiation operators. These tools are fundamental to performing calculations in Python. Next, we navigated the realm of comparison operators. We discovered how Python can compare values using operators like greater than, less than, equal to, not equal to, and so forth. We've seen that these operators return Boolean values, true or false, that can help us make decisions in our code. Then we ventured into the domain of logical operators. We unraveled how AND, OR, and NOT operators can control the flow of our code by combining conditions. We've understood that these operators can effectively manage multiple conditions at once, making our code more efficient and readable. Furthermore, we've learned to build and evaluate expressions in Python. We've realized that expressions are combinations of values, variables, operators, and calls to functions. We've mastered how to construct these expressions and evaluate them using Python's built-in functions and capabilities. And there you have it, a crash course on Python operators. Keep practicing and soon you'll be fluent in the language of Python. Until next time, keep coding.